Okay, welcome back, guys. The sixth question here, it says find the number of different ways in which the 10 letters of the word summertime can be arranged so that there is an E at the beginning and an E at the end. Okay, so first of all, I need to know that how many M's are there? I think there are 3. And how many E's are there? 2. And the rest are 5. Okay, so total we have 10 letters here. So we have to arrange them in a way that there is an E in the beginning and there is an E at the end. Okay. So these 2 E's have been utilized. They have been used here. So how many letters are left? 8. So 8 factorial over 3 factorial. Okay. That is the answer. 8 factorial over 3 factorial. And you can tell me what is this value? 6? 7? Okay, 6,720. Okay, let's see what is in the next part. Find the number of different ways in which the 10 letters of the word can be arranged. Remember this arranged, that is for the NPR or for the factorial thing. So that E's are not together. So one way of doing is that you find the number of arrangements where E's are together. So you make both the 2 E's look like as one thing, okay? So that means the remaining 8 letters plus 1 this. So 9 letters, 9 objects have to be permuted in which there are 3 M's, okay? And if you want to write 2 factorial for the 2 E's, you will have to divide by 2 factorial as well because they are both the same. Okay, this is one way of doing this. You can find this answer. We have learned another way of finding such arrangements where we keep certain items away from each other. That is where, like, you have 8 E knots. Okay? 5, 6, 7, and 8. So here are the slots where you can keep these 2 E's. And how many these slots are? These are 9. Okay. Now, should I write 9C2 or 9P2? Huh? 9C2 because the E's are same. If these were 2 different people, 2 different objects, so then I could have kept here 9P2. 9C2 times 8 factorial divided by 3 factorial. Please make a check. Both of them should be having the same value. So what is the answer, Bacho? 60,480. So both of these should be 60,480. Okay? I hope it's clear. This has to be total minus where you have subtracted the ones where they are together. So both these answers should be same. I forgot to write the total minus where they are together. 3 factorial into 2 factorial. Yeah, so they should match. I just forgot to write this one here. Okay, so this is the number where 2 E's are together, and this is the total number of arrangements. So you subtract them, you get the number. Now this can only be done when you have 2 things, okay, and you don't want them to be together. Otherwise, this is the method which can be used in any of the cases here. Like you have 2, 3, 4. Remember, there was a question that there are 7 men and there are 4 women, and we don't want any women to be next to each other. So, like 7 men and then 8 slots for those women. Okay. So let's go to the next part. It says 4 letters are selected from the 10 letters. Okay. Find the number of different selections. Guys, you need to underline the word selection here. Find the number of different selections. Okay. If 4 letters include at least 1 M and 1 E. 1 M and 1 E. Okay, let me erase this first and then we are ready for this. Okay, so we need to have, like, there are some certain conditions on E, certain conditions on M, and these are the others. Okay, you have two E's, you have three M's, and there are five of the other letters. It says there should be exactly one E, at least one M, and altogether we need to have four letters. So I'm going to fix one here. If I take one from here, I can have two others. This is one, I can have two M's. This will be one from here. I can only have one E, I can have three M's, and there will be no one from here. So these are the combinations that can give us four letters following these conditions. So this is going to be 5C2. Should I write 3C1 into 2C1 into this 3C1 into this 2C1? Do we really have to choose from, like, if there are three M's and we're choosing one M from them? No, we don't do that. Okay. So therefore, this will not be written here. So this is 5C2 plus 5C1 plus 5C0. So this is 16. Okay. And we can check the answer as well. This is question number 6. Yeah, this is 16. Okay. And now we head towards the last question of this paper. I'm really waiting for that part on the geometric distribution because that is a new addition to your syllabus. Okay, the geometric distribution. Okay, on any given day, the probability that Moina messages her friend Pasha is 0.72. Okay, Moina is a Veli person. She is Pasha. Now, okay, let's forget about Moina and Pasha. I was going to talk about them. Okay, so find the probability that for a random sample of 12 days, Moina messages Pasha on no more than 9 days. What kind of distribution is this? Binomial. Okay, so we shall have let X is binomially distributed with this 12 and this is 0.72, and we have to find the probability that X is at most 9, no more than 9. Anna? Sorry, less than or equal to, less than or equal to. I'm writing this wrong here. Less than or equal to 9. So this is easier to find it as probability X is more than 9 because there are lesser possibilities towards the right of this. So 1 minus probability X equal to 10 plus probability X equal to 11 plus the probability X equal to 12. That is how we'll do that. So we have 1 minus 12C10 into 0.72 raised to power 10 into 0.28 raised to power 2 plus 12C11 0.72 raised to power 11 and then 0.28 raised to power 1 plus 12C12 0.72 raised to power 12 and then 0.28 raised to power 0. Please give me what is the answer. So this is 0.696 and that is the right answer. Okay. Next it says Moina messages Pasha on 1 January. Find the probability that next day on which she messages Pasha is 5 January. He's confusing us by telling us that she messaged her on 1 January and next she is going to message on 5th January. So that means she did not message him on 2nd, 3rd and 4th and she messaged him on the 5th. Maybe her balance was over, your package was gone. Okay, so this is a kind of a geometric distribution. Okay, so we can say that, guys, do you understand this is a geometric distribution? Because in a geometric distribution, let me tell you how do we note it down. So this is going to be, let X is geometrically distributed, and we only write the probability of success. And here we're going to find the probability that X is equal to 4. Because you know this, the message is happening on the fourth trial. Okay. So that is going to be Q cube times P. So 0.28 raised to power 3 times 0.72. That is how you will find that. Okay. So this is just one part given on the geometric distribution. What is the answer? 0.0158. So that should be the right answer. Okay. So let's move on to the last part then. Okay. Use an approximation to find the probability that in a period of 100 days, Moina messages Pasha on fewer than 64 days. So first of all, this is a binomial distribution. 100, and we are talking about messaging. That is, the probability of success is 0.72. And we have to find the probability that X is less than 64. Guys, you have to be very careful with the equal mark over here, okay? So we can find this using the binomial distribution itself. So we have been given the instruction that we have to use an approximation. So this is a situation where we'll be going from the binomial to the normal distribution. And see, this is a very expensive part here, 5 marks. That is 10% of your whole paper. Okay, so you will be going from the binomial to normal. So now you will say, okay, let y is normally distributed. So when you have a normal distribution, you have to provide its parameters. What are the parameters of a normal distribution? The mean and the variance. Okay. So we can find the mean from this binomial distribution. The formula is NP. Okay. Please tell me what is 100 times 0.72. That is 72. So the mean is 72. And we will find the variance. That is NPQ. 72 times 0.28. What is this? 20 point? Okay. So this is the variance that we have. Okay. So I would say now, okay, finding the probability X is less than 64 is like finding the probability Y is less than. Now here is the point where you do that continuity correction here. So would that be less than 64.5 or less than 63.5? 63.5, because 64 is not included here. Okay. So if you don't do that correctly, you can lose 2 marks out of these 5 marks here. Okay. This is less than 63.5. And then you standardize in the same line here. So this would be Z is less than 63.5 minus the mean, which is 72, over the standard deviation. Many of you forget to put the square root sign on this. Guys, you get the variance from this NPQ, okay? So what is this? This is phi of what? 1.893 minus 1. Yeah, minus 1.893. So this will be 1 minus phi of 1.893. Please look at this. Look at the table and tell me what is this phi of 1.893. Yeah. 0.9706. 0.97? 0.9708. Okay. So do that 1 minus with that. 0.0292. Okay. So that is the probability that Moina messages Pasha's G less than 64 days. Okay. And I think that this ends the paper as well. Okay, that's a good news. So we have done that in less than an hour. Okay. Thank you very much for being with us, guys.